This is our Coulomb's law from the field of electrostatics. So we see here we have the point charge Qn and it is a positive charge. We have another point charge Q2 and it is a negative charge. That's why we write plus Q1 and here we write minus Q2. So if these 2 point charges are placed close to each other and they are opposite to each other, it means this is a positive charge and this is a negative charge, then they will exert force on each other. For example, this positive charge Q1 will exert a force on charge Q2 indicated by blue arrow and is written as F12. That means force of charge 1 on charge 2. Similarly, this charge will exert force on Q1 and it can be written as F21, that is the force due to charge 2 on charge 1. Small r represents the distance between the two charges, okay, and the magnitude of these force F12 or F21, they are equal, so their magnitude is equal. Therefore we can write magnitude of F12 is equal to magnitude of F21, and that can be equated to Ke in the, and we take the magnitude of the two charges Q1 multiplied by Q2. Even though they are opposite charges, we take their magnitude Q1 into Q2 and divide it by distance between the two, that is r, square of it. So this equation tells us that Coulomb's law states that it relates the 2 point charges and the force between them, and it equates that force equal to the multiplication of these two charges, and it is inversely proportional to the distance between, square of the distance between these two. So if the distance between the two charges is smaller and smaller, this force F12 or F21 gets larger and larger, and that relationship is non-linear. Okay, now what if the two charges Q1 and Q2 are both positive in nature? You see here, this is positive and this is also positive. So again, the force exerted by Q1 on Q2 would be F12, but it will be shown as given by this arrow. Because they are the like charges, they will repel each other. Similarly, force 2-1, that is force of charge 2 on charge Q1 would be F21, and it will be shown by the arrow. Third example, let's say you have two charges and both are negative charges. Here also they are of the same polarity, so you can say that their forces would be repelling to each other. The charges will be repelling to each other. This is the distance r between these two. So we understand the Coulomb's law. This is quite widely used in electrostatic, for example parallel plate capacitors, and so many applications are based on this.